All right, our next unit is going to be on area, and we're going to pick up where we left off. We're going to talk about the area of the different kinds of quadrilaterals first. Okay, remember that kites, they have two distinct pairs of congruent sides. Okay, and to find the area of a kite and a rhombus, actually, you multiply the lengths of their diagonals and then divide that by 2. Okay. I don't really know what 2 things you were supposed to remember, but do remember that their diagonals are perpendicular. Okay. So here, example 1, we're going to just jump right into it. Okay. It tells us that BD is 8 centimeters. That's one of our diagonals. CE is 12 centimeters. That's the entire length of our second diagonal. So area is 1 diagonal times another diagonal divided by 2. Okay, 8 times 12 is 96, and 96 divided by 2 is 48. Okay, it's important to know that area is also in units squared. So the area, your final answer would be 48 centimeters squared. Okay, example 2, we start with the area. Okay, we know the area it's given to us, and we know that PR is 6 yards, and we want to know how long the second diagonal is. Okay, so I'm just going to substitute these values in to this equation. Okay, I know my area is 30. 1 diagonal is 6. I don't know the second diagonal. Okay. First thing that I like to do is multiply both sides by 2 to get rid of the division. Okay. 2 times 30 is 60, and we are left with 6 times the second diagonal. And we will divide both sides by 6. So SQ is 10 yards. Okay, so if your answer is an area, it's units squared. If it's just one side or one part, it's just regular units. Okay, next is trapezoids. Trapezoids have 1 pair of parallel sides, and those parallel sides are called the bases. Okay, so in this picture here, we've got 1 base, 2 base. Okay, and please remember the height has to be perpendicular to both bases. All right, so base 1, base 2, and then here I am going to put that right angle symbol in, and that dotted line represents our height. To find the area, we take 1/2 times the sum of the bases times the height. Okay, so I like to label my parts when I'm looking at these pictures. Okay, it does not matter which one gets base 1 and base 2. Okay, if you like putting the small number as the first base and the bigger number as the second base, that's totally fine. Okay, that right angle symbol is going to help us find our height. So again, I'm just now going to substitute those values into this equation, okay, because I'm trying to find the area. I said my first base was 4. I said my second base was 8. And my height is 6. Okay. We need to do what's inside this set of parentheses first. 4 plus 8 is 12. Okay, and then we can just multiply these straight across in whatever order. 1/2 times 12 is 6, and 6 times 6 is not 33. It's 36. And then our units would be feet squared. Okay, this next one, I'm looking for my height. I don't know what that is, but I have both of my bases. My area is 90. I know both of my bases. Those were given to me, but I don't know my height. Okay. Similar to the kites, one practice that I get into is I multiply both sides by 2 first. Okay, that eliminates the 1/2. All right, 2 times 90 is 180. 8 plus 12 is 20 times our height. And to get that height by itself, divide both sides by 20. And my height is 9 centimeters. Okay. Last one here. This one's a little different because we are missing one of our bases. Okay. 10 is my height. 19 is my second base. My area is 160. I don't know my first base. My second base is 19. My height is 10. Okay. And again, I like to get into the practice of multiplying both sides by 2 to eliminate the 1/2. Okay, I get 320 equals B1 plus 19 times 10. I now can divide both sides by 10. So I know 32 equals my first base plus 19, and then subtract 19 from both sides. To get 13 millimeters for that first base. Okay. And last but not least, parallelograms. And this works for all parallelograms. Okay, so if you were paying attention earlier, we've got 2 different ways we can find the area of a rhombus. And technically 2 different ways we could find the area of a square. But personally, I think this equation was a lot easier. Okay, parallelograms have 2 pairs of parallel sides. All right. And we just need to multiply base times height. Okay. The base and height are always perpendicular to each other. Okay. So moving into examples. Here, this is perpendicular to 9. 9 is my base, 7 is my height. Base times height tells me that the area of this parallelogram is 63 meters squared. Okay. This next one is a rectangle. Base and height are given to me again. So I multiply 6 times 8 for an area of 48 square inches. Okay, now there's a lot going on here. Okay, but remember, here 5 is my height. I want to know what it is perpendicular to. Okay, that right angle symbol touches this side down here at the bottom. So 6 is my base, 5 is my height. When I multiply those, I get an area of 30 square meters. Okay. The number 4 here, and this time we are given the area. Okay, and we don't know that base. You'll notice here, my height lies outside of my parallelogram, and that's okay. All right. We still only are going to be finding this portion. Okay, this part out here does not matter. All right, but again, I know my area is 72. I don't know my base. I know my height is 8. So to find that base, I'm going to divide both sides by 8. My base is 9 meters long then.